Have you ever held a piece of silver jewelry, a shiny coin, or an antique spoon and wondered, where does this incredible metal actually come from? It's not just dug out of the ground looking perfect and polished. The journey of silver from a rugged ore deep within the earth to the beautiful objects we treasure is a fascinating story of geology, chemistry, and human ingenuity. Today, we're going on that journey to uncover exactly how silver is made. First things first, where do we even find silver? Pure silver, what we call native silver, is actually quite rare. You might find it in nuggets or thin, thread-like strands, but this isn't where most of the world's silver comes from. The vast majority, over 2/3 in fact, is mined as a byproduct of other metals. Think of it as a hidden treasure locked inside ores of copper, lead, and zinc. Major silver-producing countries like Mexico, Peru, and China are often mining these other metals and extracting the silver along the way. These ores, like argentite, which is a silver sulfide, are the real starting point. So miners head deep into the earth. They use massive machinery and controlled explosions to break apart rock and access these metal-rich veins. The rock they pull out is called ore. This ore is a jumble of valuable minerals and a whole lot of worthless rock, which we call gangue. The initial challenge is separating the good stuff from the junk. The ore is transported from the mine to a processing plant, where it's crushed and ground into a fine powder. This is a crucial step because it increases the surface area, making it easier to get the silver out. It's like trying to get sugar out of a sugar cube versus loose sugar. The smaller the particles, the easier it is to dissolve and separate. Now for the really clever part, getting the silver out of that powder. One of the most common methods used for centuries is called cyanidation. I know, it sounds a bit intense, but it's a brilliant chemical process. The powdered ore is mixed into a big vat with a weak solution of sodium cyanide. As this mixture is stirred, the cyanide solution selectively dissolves the silver and gold particles, creating a chemical complex that holds the silver in the liquid. The rest of the rock powder doesn't dissolve. This slurry is then filtered, separating the silver-rich liquid from the solid waste. We now have our silver, but it's trapped in this cyanide solution. How do we get it out? The answer is zinc. By adding zinc dust to the solution, a chemical reaction called cementation happens. The zinc is more reactive than silver, so it essentially kicks the silver out of the solution, taking its place. The silver precipitates out as a solid sludge, a dark, heavy powder that sinks to the bottom. This sludge isn't just silver. It might also contain gold and other metals that were in the original ore. This sludge is then collected, dried, and sent to a smelter for the fiery finale. Smelting involves heating the material to incredibly high temperatures in a furnace. This process has a few goals. First, it burns off any remaining impurities. Second, it melts the metals. Since different metals have different densities, they separate into layers. The heavier silver and gold sink to the bottom, while lighter impurities, called slag, float to the top and can be skimmed off. The molten metal mixture that's left is called doré, a semi-pure alloy of silver and gold. It's poured into molds to form large bars, which are now much more valuable than the rock they came from. But we're not done yet. These doré bars are valuable, but they're not pure silver. The final step is refining, and this is where we get the 99.9% pure silver we're familiar with. The most common refining method is electrolysis. The doré bar is used as the anode, the positive electrode, in a special electrolytic cell. A thin sheet of pure silver acts as the cathode, the negative electrode. Both are submerged in an acidic electrolyte bath, often a silver nitrate solution. When an electric current is passed through the cell, the silver atoms on the surface of the impure doré bar lose electrons and dissolve into the solution as positive ions. These silver ions then travel through the electrolyte solution over to the pure silver cathode. There, they gain electrons and plate onto the surface as pure silver metal. It's like a magnetic attraction, but for atoms. The beauty of this process is its precision. The gold and other less reactive metals, like platinum, don't dissolve. They simply fall to the bottom of the cell as a valuable sludge, which is collected later. Meanwhile, more reactive metals like copper or lead do dissolve, but they stay in the solution and don't plate onto the cathode. Over time, the pure silver cathode grows larger and larger, accumulating layer after layer of ultra-pure silver. The original impure doré bar shrinks away to nothing. Once the process is complete, these cathodes are removed. They are now 99.9% pure silver, or 3/9 fine. This pure silver is then melted one last time and cast into final forms, like large commercial bars, smaller ingots for investors, or grain-like shot for jewelers and industrial users. And it's from this pure silver that everything else is made. For jewelry and silverware, it's often mixed with a small amount of copper to create sterling silver, which is 92.5% silver. This makes it harder and more durable for everyday use. For electronics, its superior conductivity is put to use in switches and circuit boards. For photography, its light-sensitive properties were the foundation of film. The journey is incredible, from a humble rock pulled from the dark through crushing, dissolving, precipitating, smelting, and finally, atomic-level purification. So next time you see a silver ring or a gleaming bullion bar, you will know the immense effort and brilliant science that transformed it from a hidden component of rock into a precious metal. It's a testament to our ability to unlock the planet's hidden treasures. Thanks for watching, and if you enjoyed this deep dive, don't forget to like and subscribe for more amazing stories from the world of science and engineering. See you next time.